Les Stockley and welcome to this video. Tonight I'm going to talk about servo selection and installation. Pretty much what you're looking for in a servo for a particular job and how to get a good solid mounting, and a few little hints and tips in that general direction. Okay, so this is a fairly typical fuselage installation for one of my models. Things to note: okay, you'll see the servos are hard mounted in with some screws directly into the servo tray. There's no rubber grommets or anything like that. Okay, the servos are hard mounted. There's no vibration in a glider, so there's no need for those little rubber grommets that they give you. The elevator servo, it's the biggest servo that I could fit in there. Reason for that is on an all-moving elevator like this one, you want a decent set of gears to resist stripping and things like that. Rudder servo, it's small, compact, powerful, digital, as are all my servos in these sort of models. Battery monitor, okay, all my models have one in for 20 bucks. It's cheap insurance. And you'll notice this different sort of switch here. Okay, a few years ago I read an article about the typical switches that come with a model being good for about 5,000 contact cycles. These ones are good for about 50,000 contact cycles, so it's just a small switch. You can buy them from JCar or Dick Smith. Okay, and you'll see the LED readout from the battery monitor. Good quality clevises. Okay, don't skimp and buy the cheap ones, and I use the metal ones as well. Makes it easier. Okay, and the receiver's up front here, and up in the nose here I run a 5-cell battery pack, and that's mostly for holding torque during a launch, not necessarily for speed, but for the holding ability. And here's another one of my models, essentially the same. Only difference here is the servos are side by side. Once again, hard mounted in, no rubber grommets, no shock absorbing there. Good quality componentry. Okay, this is quite a trick little connector here I got from Europe a few years ago. Very handy for getting in tight spaces. Same switch again, and same battery monitor. Okay, it's actually very cheap. Okay, here we have the servo set up in a discus launch wing, so it's very lightweight. It's a Kevlar skinned vacuum bagged wing. Okay, this is obviously a very small servo, lightweight, doesn't need to be retained so well. Okay, this is hollowed out, the blue foam here, and it's been glued in just with some 5-minute epoxy. Simple as that. And there's actually a layer of clear tape over the top as well. I'm not sure if you're going to be able to see that on the video, and that's just to help retain it. Okay, nice lightweight, simple linkage directly to the servo. Okay, this is one of my F3B models. Just be careful with the light here. The servo in this wing, these ones are installed in a plastic mount. The plastic mount's glued into the wing, and then the servo's screwed into the mount. Makes them easily removable should you need to for on-field repairs. Okay, that's the flap servo. Once again, that's the biggest servo I can fit in there. And down here, the aileron servo. Okay, mounted exactly the same way. It's in a plastic frame, which makes things nice and removable. Metal clevises, good quality hardware, and no problems so far. Okay, and what we have here is this is an aileron servo off of one of my Supras that I'm taking to the World Champs. Okay, and this is the other way of doing it. It's just quite simply, you can see the 5-minute epoxy, it's just glued in. Okay, I mix up my 5-minute epoxy with a little bit of glue powder as opposed to micro balloons, just to make it a slightly better glue. Put a bed in there and clean the servo up and pop it in, wait it down till it's dry, and away it goes. Now this servo I'm not sure if you're going to be able to see it, is actually butted up against the back of the spar, so it's nice and rigid. Okay, and you also will have noticed on the top here there's a piece of carbon. Okay, it's just a piece of carbon toe. It's been set on the servo, set on the inside of the wing skin and lifted up, and had some fin cyno wicked into it. Okay, and what that does is in an FRJ launch especially, these servos, they see a lot of load, and the common failure point for them is that the pressure from the control surface back to the servo makes this servo bit sort of basically flutter up and down if the wing skin isn't rigid enough. Okay, so by tying the top wing skin through the servo, through this piece of carbon to the bottom wing skin, okay, you reduce that, you create a much tighter unit, and it's much better able to resist flutter and any problems like that. So there you go. That's hopefully a few little pointers to help you achieve a nice solid servo mounting, and help you make some decisions on choosing the right servo for the job. Thanks.